Hello. In this video, I'm going to be talking about exponents, and I'm going to spend more time on the rules of exponents or the rules of powers. Okay, let's begin. So, when we talk about an exponent, we are talking about how many times to multiply a number by itself. So, an exponent gives us an idea of how many times to multiply a number by itself. And what that means is this. So if you look at this exponent, b to the power n. Now, b is called the base, and n is the exponent. Now, sometimes the exponent is called the power. So if you see power or exponent, it's the same thing. So the n is our exponent. And to say that, we say b raised to the power of n. B raised to the power of n, or b raised to the power n. An example is this, 5 to the power 3. So 5 to the power 3 means you are multiplying 5 3 times. So you've got 5 times 5 times 5. Now remember, this is not the same as addition. This is not the same because this equals 15. We are looking at multiplication, times. So 5 to the power 3 means that you're doing 5 times 5 times 5. Okay. Now, there are some properties or rules that you have to remember with exponents, and I need you to use them, especially in our assignments or homework. So let's start. The first one is the product rule. Now, the word product in mathematics means that we are looking at a result. The result from multiplication. So, if I multiply two numbers, 2 times 3, the product of 2 and 3 is 6. 6 is our product. So the result from multiplying numbers is called a product. All right. So just by remembering what product means in mathematics, it should tell you what kind of rule this is going to be. It has to have something in it with multiplication. Multiplication. All right. So let's look at it. So you have a as a non-zero real number, and m and n are going to be integers. Then a to the power m times a to the power n equals a to the power m plus n. So anytime you are multiplying exponents with the same base, a, you add the exponents. This is called the product rule. The product rule. Let's look at some examples. So for a, I've got x to the power 2 times x to the power 4. Yep, I've got x and x as the base. So the rule says you've got to add 2 plus 4, which gives you x to the power 6. Now, for b, we have a times b to the power 6. The first thing you need to watch out for are the bases. Now, for any number like a, 2, it always has an exponent of 1. 1. 2 to the power 1 is just 2. A to the power 1 is just a. So we've got a times b to the 6. Now, because the bases are not the same, we've got a and b, we are not going to be able to apply the product rule. So this will just equal a times b to the power 6. It's kind of the same thing because the bases are not the same. Now, 4 to the power 2 times 4. Now, 4 again is going to be to the power 1. So I've got 4 to the power 2 plus 1, which is 4 to the power 3, the product rule. Now, for the next one, I've got 2 to the power 3 plus 2, which is 2 to the power 5. And then for this last one, I've got negative 2. Now, the negative 2 is in parentheses, meaning that everything here is going to have the effect of the 4. So you've got negative 2 to the power 4 times negative 2 to the power 3. This should give me negative 2 to the power 4 plus 3, which is negative 2 to the power 7. Negative 2 to the power 7. This is the product rule. This is the product rule. All right, let's talk about another rule. Now, this rule is the quotient rule. The quotient rule. Now, the word quotient in mathematics means that you're looking at the result from dividing numbers, from division. So again, even before you know the rule, you know that we're going to be dealing with a division thing. So this rule states that if you've got a non-zero a divided by that, or I could rewrite this as a to the power m divided by a to the power n. This would equal a to the power m minus n. So anytime you're dividing exponents with the same base, you have to subtract the powers, m minus n. So as an example, let's say that we've got 4 to the power, let's do 4 to the power 5 divided by 4 to the power 3. This would give me, because I've got 4 and 4 as the base, 4 to the power 5 minus 3, which gives me 4 to the power 2. And 4 to the power 2 is 4 times 4, which is 16. Okay, another one. So let's say that we've got 2 to the power 9. 2 to the power 9 divided by 2 to the power negative 2. 2 to the power negative 2. Again, the same rule applies. 2 to the power 9 minus negative 2. And you know that a negative times negative is positive, so you've got 2 times 9 plus 2, which is 2 to the power 11, which means you're multiplying 2 by itself 11 times, 2 to the power 11. So it doesn't matter if the exponent is a negative or positive. It doesn't matter. Just apply the rule like I did with this problem. Just apply the rule, and that's it. All right. Now I'm going to combine the product and then the exponent, the product and quotient rule. So let's say that we've got 2 to the power 4 times 2 to the power 2 divided by 2 to the power negative 3. So I'm going to deal with the top first. 2 to the power 4 times 2 to the power 2 is 4 plus 2. And then I have 2 to the power negative 3. This gives me 2 to the power 6 divided by 2 to the power negative 3. Now I'm going to apply the quotient rule. 2 to the power 6 minus negative 3, which gives me 2 to the power 6 plus 3, which gives me 2 to the power 9. So I've applied both the quotient rule and the product rule. All right. Now I want to try to break down the quotient and then the product rule for you for it to make more sense. And I'm going to use this example first. So let's say that we've got 2 to the power 7 divided by 2 to the power 5. Now we know that this should give you from the product root 2 to the power 2, 2 times 2, which is 4. Now to break this down, I'm going to say that 2 to the power 7 is 2 times 2, 7 times 2, 1, 2, 3, 4. I've got 3 more. 1, 2, 3, 4, 5, 6, 7. Okay, got 7. And then at the bottom, I've got 2 times 2 times 2 times 2 times 2. So, of course, the top is 2 to the power 7. The bottom is 2 to the power 5. Now, because these two are dividing, you could cancel out because 2 will go into 2, 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 2 will go into 2. So at the bottom, I'm going to have 1. Now, on the top, I have 2 times 2, which is 4. So the basic idea with these exponents is seen in this, that if you open it up and then cancel or divide, kind of reducing it to its lowest term, cancel out the 2's, you would see that this rule works perfectly. And it is also the same with the product rule. Let's check it out. So if I have 2 to the power 3 times 2 to the power 2, 2 to the power 3 is 2 times 2 times 2. And then 2 to the power 2, again, it's multiplying, so I'm going to do times 2 times 2. So we've got 1, 2, 3, 4, 5, which is 2 to the power 3 plus 2, which is 2 to the power 5. Wow. So that is the idea behind the product rule and the quotient rule. Now let's talk about another rule, and that rule is called the power rule. The power rule. If I have a to the power m raised to the power n, so here I've got my m, and then there I've got n. This is called the power rule, and the rule states that you should do that. A to the power m times n. This is the power rule. So if I have 2 to the power 3, and then I've got 4 here, this gives me 2 to the power 3 times 4, which is 2 to the power 12. 2 to the power 12. The power rule. And this would make sense because if you have 2, I'm going to just use just this example, the same example, 2 to the power 3 and then 4. So 2 to the power 3 has to multiply itself 4 times. 4 times. So you're doing 2 to the power 3 times 2 to the power 3 times 2 to the power 3 times 2 to the power 3. And each one is 2 to the third power, which means you're doing 2 times 2 times 2 times 2 times 2 times 2. So I've got this and then I've got that. Same thing, times 2 times 2 times 2. And then 2 times 2 times 2. And you would see that these will be 12 of them, 2 to the power 12. This is called the power rule. The power rule. Another rule, another rule. The zero exponent rule. The zero exponent rule. Zero exponent rule. This states that if you have a non-zero number, a to the power zero, this should always give you a 1. So any number to the power zero is 1. Any number to the power zero is 1. And this is called the zero exponent rule. The zero exponent rule. Another rule is going to be the negative exponent rule. The negative exponent rule. A to the power negative m. So it's got a negative exponent. This will equal 1 over a to the power m. A to the power m, which means if I've got a negative exponent, I could just bring it down, and then on top, I'm going to have 1 as the numerator. So 4 raised to the power negative 5. This equals 1 over 4 to the power 5. 1 raised to the power 2/3. This equals 2 to the power negative 3. This is the negative exponent rule. The negative exponent rule. The negative exponent rule. Now, I want to also talk about something else. These are not really rules, but they're extension of the quotient rule. The quotient rule. Let's say that I've got, I've got, okay, a over b to the power m. Now remember, the m must be distributed in some way to both of these. So this should equal a to the m divided by b to the m. You seen it? Mhm. So it's because a over b is a fraction. So in the end, if you're doing 2/3, oops, I'm going to change the m to probably a number. So let's do 2/3 raised to the power 5. Now the 5 affects 2/3, right? So you're going to have 2 to the power 5 over 3 to the power 5, like that. So you should remember that. And then also an extension probably to the power rule. If you have a, b to the power m, like that, ab is multiplying, but the m is going to affect both of them. It's going to affect a, is going to affect b, like that. It's going to affect both of them, which means if you have 2x raised to the power 2, you're going to have 2 raised to the power 2, x raised to the power 2, like that. 2 raised to the power 2 is 4x squared. So that's the idea behind these. So I'm going to end this video here, and then I'm going to continue in another one. All right, bye.